Hi guys, so this is just the end of this lesson from today. So your home learning is just going to be to make some notes off this page. I'll just explain them. So you can just pause the video, make the notes, and then you're done. So this was just the end of the lesson. I know a lot of you have already drawn this, but it was just to show you the crest and the trough of the wave, and then the amplitude from the centre upwards. And then here's the wavelength drawn from the centre of one peak or crest to the other here. You can call a crest a peak or a crest. You can draw the wavelength from trough to trough, okay? Or you could draw it from here to where that repeats again there. That would be a wavelength too. So let's have a look at the next slide. So here's a wave drawn on a graph. So you've got the amplitude here is 15 centimetres. 15 centimetres. And then the period of the wave is the time for one wave. So if we follow the wave to where it repeats here, we can see that the time period is 20 seconds. So if you want to calculate, which I've written here, if you want to calculate the frequency of the wave from the time period, then all you do is 1 divided by the time period. So in this case, the frequency is 1 divided by 20. There's the 20, okay? So that gives you a frequency of 0.05 Hertz. What frequency tells you is how many waves there are per second. So this wave takes 20 seconds. So there's less than one wave in 1 second. 1 second's here. So you're getting a tiny bit of the wave. In fact, you're getting 0.05 of it. So frequency tells you the number of waves per second, and you calculate it as 1 over the time period. Pause the video here and make a note of that. Okay, next thing you need to do is the wave equation. So there's two wave equations you can use for the wave equation. There's the speed of the wave is equal to the distance the wave travels divided by time. This is incredibly helpful for things like waves on the sea that are moving a certain distance in a certain time. You can also calculate the wave speed from its frequency times its wavelength. So please write this equation down. You can see here the units. Wave speed is meters per second. Frequency is measured in hertz. Wavelength is meters. So we're going to use this equation here in an example. So here's an example. What speed does a wave of wavelength 2 meters and frequency 3 hertz travel? Why don't you try using this equation here to figure that out? Press pause and then see if you've got the right answer. Okay, so I'm going to substitute the values into the equation. Frequency was 3, the wavelength was 2, so you get 3 times 2, which is 6. So this wave is travelling 6 meters every second. That's quite a simple example because the numbers we've used are quite small. Make sure you've got the right answer and then you can move on. So here's example 2. The wave speed in this case is 300 and there is a frequency of 3 kilohertz. Now kilo is 1,000, so this is 3,000 hertz. Now in this case we don't want the wave speed, we want the wavelength. So when we use this equation, wave speed equals frequency times wavelength, we already know the wave speed is 300. So if we substitute that there, we know the frequency is 3,000, so substitute that there. And then we have the wavelength here that we want to figure out. Because we want the wavelength, we need to cross multiply this over here. So 300 divided by 3,000, because it's multiply on this side, take it to the side it's divided by, will give you the wavelength. So that's 0.1. The last example is probably the most difficult example because we're going to use an electromagnetic wave. So electromagnetic waves all travel at the same speed. So remember, the electromagnetic waves are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Now the speed of the wave is 300 million meters per second. So all those waves travel at that speed, 300 million meters per second. Now this particular wave has a wavelength of 300 meters, okay? So radio waves used for broadcasting have quite long wavelengths. Compared to this one, this is 0.1 and this is 300 meters, so it's quite big. In this case, we want to work out the frequency of the wave. So if we look at the equation, wave speed is frequency times wavelength. The wave speed is 300 million, so we've got that there, substitute in. We don't know the frequency and the wavelength is 300 here. So what I need to do is, this is multiply here, so I need to take it to the other side and divide. So 300 million divided by 300 will give me the answer. When you do that, you get a million. So the frequency is 1,000,000 hertz. We can say that that's the same as 1,000 kilohertz, because remember 1,000 is K, so we've got 1,000 kilohertz. We can also call that a megahertz. So a megahertz, mega means 1,000,000, so 1 megahertz is 1,000,000 hertz. But if you were in an exam, you'd be fine to write this answer down. Okay, I'm going to do more practice on that next lesson, but that's the end of what I wanted you to do today. So can you just make sure that you understand that as much as you can. If there's anything you're not sure about, highlight it in pink, and then we can just discuss it at the start of next lesson. Thank you very much. See you soon.